Hey friends, my name is C and welcome to a new video for IGCSE Geography, and today we have a new video for Theme 2 for 2.2 Rivers. And here are the specifications from the website, right here. And here we have one case study in this video, which is a river or rivers, their associated hazards and their management, which we'll look into the Nile River later. So starting with some notes and some key terms for rivers. So the key terms here are erosion, transport, deposition and discharge. So erosion, starting with erosion, it's the wearing away of the Earth's surface by a moving agent. And for transport, it's the movement of a material via a process, and in the context of rivers, it's via a river process, which we'll look into later as well. And then we have deposition, which is the laying down of a material carried by rivers or the sea because of a reduction of velocity or discharge. So basically, when the material loses energy due to, let's say, the river water slows down, it will lose energy and it will get deposited at the side of the river or in the riverbed. And then we have discharge, which is the volume of water passing a certain point per second, or per unit of time. And because it's the volume per unit of time, this means the unit will be in cubic meters per second. So here are some notes. We have number 1. A river is a large and natural stream of flowing water, and its purpose is to erode the river channel and to transport materials and so on. And because rivers can be found in different parts of the hill or the mountain, for example in the higher part, the middle part or the lower part, because of its different height and different features and different characteristics, this means there will be different landforms at different parts of the river. And as I mentioned earlier, the energy of a river determines its ability to erode, transport, and deposit materials. So let's say if it has high energy, then it'll erode faster and more powerfully, and it'll transport a material further along the river, and it'll deposit less because it has a lot of energy. So transport and deposit basically is the opposite. And the efficiency of a river's shape is measured by its hydraulic radius. And it's basically that the higher the hydraulic radius, the more efficient a river is. So here we have a little diagram. We have the riverbanks, the bed, and the river with a cross-sectional area and the different lengths and heights. So the hydraulic radius is given by the cross-sectional area divided by the wetted perimeter. And here we have basically the calculation. So the hydraulic radius for this specific river is 1.87. As I mentioned earlier, the higher the hydraulic radius, the more efficient the river is. And last point, the channel efficiency is measured by the hydraulic radius, or the cross-sectional area, divided by the wetted perimeter, which I just mentioned. And here is a quick note of what wetted perimeter is. The wetted perimeter of a river channel is basically the part that is in contact with the water. So as I zoom into this diagram here, this part here is the wetted perimeter. And these parts aren't the wetted perimeter because they are not in contact with the water. Then we have drainage basins and some key terms. So we have drainage basin is an area of land drained by a river system, and specifically a river and its tributaries, or it's like small streams, small rivers, as shown in this diagram over here. So we have some key terms and some are quite straightforward. For example, precipitation, which basically means rain most of the time. Tributary is a stream or river that joins a large river. Confluence is a point at which two rivers meet. So in this diagram here, we have one river going in this way and the other one down here. That means this point here is the confluence. Watershed is a ridge or other lines by which basically separate two river basins. So we have this watershed right here, right? So this means that this is one of the river basins, and the other one here could be the other river basin, which has a watershed of, let's say like this. So watershed basically divides the different drainage basins. And then we have hydrological cycle, which is basically the water cycle. And then we have groundwater, which is quite straightforward, which is basically where water is stored underground in a permeable rock, where water can flow through. And some notes is that a drainage basin is an area of land where all surface water is drained by a river and its tributaries. And drainage basins are divided, as I mentioned, by watersheds, because it's basically the land over here. And one quick note is that the watersheds, which are basically the border, typically have a higher land, like higher altitudes. And the main input to a water cycle or the hydrological cycle is via raining or precipitation, like rain, hail, or snow, because that's one of the ways how water gets introduced into the system. And throughout the whole cycle, water can be stored in vegetation, surface, and groundwater, and etc. Then we'll look more into the hydrological cycle. So we have the different processes or different keys in the cycle. We have the input, storage, flow or the transfer, and the output. So input to the cycle is, as I mentioned, precipitation, where the water basically falls on the earth via rain, hail, or snow. Storage is quite straightforward, where it's basically how water is stored throughout the whole process. And the precipitation that is collected and stored by vegetation is called interception. And then we have flow or transfer, which we have different keys here. We have number 1, infiltration, where it's the movement of water into the soil. And as we have some notes here on the rate of water entering the soil, which depends on the intensity of the rainfall, the permeability, for example, if it's like, say, chalk or like normal soil, and the extent to which the soil is already saturated with water. If it's like very saturated with water, that means water can't get through. And then we have overland flow or surface runoff. They're the same thing. And it's basically the overland movement of water after rainfall, basically along the surface. That's why it's called overland or surface. Then we have through flow, which refers to when water flows through the soil in natural pipes and between soil horizons. Then we have the main outputs, which are evaporation and evapotranspiration, where one is just like generally just evaporation, and evapotranspiration is more specific to when the water is lost via evaporation and transpiration, like via the leaves of a plant. So here is a quick diagram for the hydrological cycle. Let me just zoom in. We have the different keys, the input, storage, flow, and output. And you can see how they relate to each other. Then we have river processes, as I mentioned. There are 4 main types of erosion, and they are abrasion or corrosion, when the rocks or the lodes grind along the riverbank or bed, which wears it away. We have attrition, which is when 2 lodes in the river knock against each other. So let's say we have 1 rock here and 1 rock here. One rock here and 1 rock here. They basically collide against each other, which form smaller pieces and things break off, and this is attrition. And then we have hydraulic action, which is when the force of air and water on the cracks of the sides of rivers, causing the crack to increase in pressure and explode. So what it means is that, let's say you have this diagram here, we have these cracks right here. So they are mostly filled with water or air, right? So when the river flows, more air and more water might get into these cracks, which might increase in pressure and explode. So that's one of the ways of erosion. Then we have solution or corrosion, which is when the river water reacts chemically with the lodes and the minerals they contain. And here are the factors that affect erosion. We have the size and shape of the lodes, the velocity of the river, the gradient of the river, which affects the velocity, and how fast the water flows, basically. The pH of the river water, which affects the solution or corrosion, and as well as human impact. Then we have more notes. We have transport. We have the 5 main types of transport, and they are suspension, siltation, solution, traction, and flotation, which you can have a read and look at their diagram right here. And deposition occurs as the river slows down, and this occurs as the river floods across a flat land as the energy is dissipated. So when flooding happens, the water basically spreads around a whole land of area, right? This means that the river water loses energy as they will basically decrease in velocity or flow slower. That's why the river slows down and they're able to deposit the loads on the land. And the larger and heavier loads are deposited first, then the smaller and lighter ones later, which is quite self-explanatory. And then we have the features of deposition includes deltas, levees, slip-up slopes, oxbow lakes, braided channels, and floodplains. Then moving on, we have the long profile of a river, which basically describes the cross-section of a river from its source to its mouth. And we have some key terms over here as well. So we have the long profile here in some notes. And basically this long profile allows us to identify the upper, the middle, and the lower course of a river, and we can see the irregularities and the neck points of a river due to its different structures, like for example due to geological factors. And there are different features found in the different parts of the river, as I mentioned earlier in the first few slides. So for example, in the upper course we'll find V-shaped valleys, waterfalls, rapids, potholes, gorges, and interlocking spurs. Whereas in the middle course, we'll find features such as meanders and oxbow lakes, because they go hand in hand. And in the lower course, we'll find levees, floodplains, deltas, and terraces. And these are all due to the features of the different courses. For example, when in the higher course, upper course, it's more steep, so the river will be faster. That's why you can form these different features, which we'll look into them now. We're starting with upper course. We have V-shaped valleys, where the slopes are steep because due to vertical erosion happening in the upper course of the river due to large loads being moved and around by traction. So we have the V-shaped valleys over here. So V-shaped valleys, which causes basically so the large loads are being moved around and they erode the riverbed and river banks, causing it to form a V-shaped. Then we have waterfalls and gorges. So we have the formation of waterfall. So waterfall forms as the river flows from a soft rock to a hard rock, and the soft rock lies below the hard rock and the soft rock erodes, therefore causing an undercut. So let me just talk about this. So we have this waterfall here where we have a layer of hard rock where water is flowing through it, and then we have the layer of soft rock down here. So as the river flows through here, it'll basically flows down from the hard rock to the soft rock and falls down, and it'll cause erosion in the bottom part of the soft rock due to, let's say, attrition, abrasion, or hydraulic action, or even corrosion, right? So it'll erode this part, and over time it'll erode more and more, which forms this undercut right here, like this undercut where it's basically there's an overhang right here and an undercut, which due to gravity the top part here will fall down like so, and the hard rock will basically retreat. So we call this the retreat. So originally it was here and it retreated back to here, and that the process keeps repeating until it forms a waterfall. And then we have rapids, where it's basically fast flowing water flows over less resistant and more resistant rocks, and the less resistant rocks erode at a faster rate than the more resistant rocks, making the river steeper and faster flowing. So this diagram over here, we have some bands of hard rocks and softer rocks. So hard rocks will not be eroded as fast or as much, so it'll form rapids over here. And then we'll look into more of the different features. For example, potholes like this, where it's basically a hole in the middle, where it's caused by hydraulic action and abrasion from loads in the riverbed. And river currents trap the loads, and the water over here swells the trapped loads, which causes erosion. So it basically the rocks will fall in here and the water will swell, which basically erodes more and more. And then we have interlocking spurs, which is really similar, or it goes hand in hand with V-shaped valleys, where they are usually found together. And there will be bands of hard rock and soft rock, or where there are bands of hard rock which are harder to erode, the river will flow around these. And the bands of more resistant rocks are called spurs, and they form interlocking spurs. So for example here, these are basically hard rock, where the rivers will flow along the hard rocks like so. Then we have middle course, where we can find meanders and oxbow lakes. So in the middle course, the river channel is quite wide, much wider and flatter than the upper course, and horizontal erosion takes over instead of vertical erosion. And basically this is a meander, where it's a bend in the river channel, and it occurs due to the difference in river water and river speed. And meanders form when the water in the river erodes the bank on the outset of the river channel and deposits a load in the bank. So here's the diagram for meanders. So we have this river right here, So because this is the path of the river water, right? So this part here will have a higher velocity, and this part here will have a lower velocity. This means that there'll be deposition happening here, and there'll be erosion happening here. Same as here, where there's deposition, erosion, deposition, erosion, which means that over time, the river channel will get wider and wider. So for example, now it's this, right? In the future, it might erode greater, like this, and then it might erode much greater, and so on. Yeah, that's how meanders form. And then we have oxbow lakes, and they are the result of erosion and deposition due to meanders. And whenever there's a flood in the river water will always try to take the straightest path of the river. So for example, we have this diagram here. We have meander, where it's basically just a meandering river channel right here. So when a flood forms, because normally the river water travels in this way right here. It goes around the loop down here and back down, right? But when flood occurs, the river water will take the shortest path because everything's overflow, right? So instead of going all the way around, the water will actually just take a straight path down here, right? So like a straight path. So then this becomes the new river, or the new main stream, right? So most of the water will just flow from here to here, instead of flowing around the river channel. Around this we'll call it the oxbow lake, right? So over time, this part right here, the oxbow lake, will dry out and become an oxbow swamp, and then it become a meander scar. And as you can see, the main river channel erodes more and more, which process basically repeats all over again. Then we have the features in the lower course. So we have levees, which are natural or artificial walls on the edge of the river that blocks water from overflowing. And it's a type of coast management which we'll look into in our next video. And natural levees occur when load is deposited at the edge of the river, and this raises the height of the river channel and reduces the risk of flooding. Because for example, if this is a river channel, so let me just draw it in, let's say like this. So river channel, right? Levees basically are deposited on the side of the road, where it basically raises the height of the river banks. So these are levees, where basically they raise the height, which means that it's harder to flood. Then we have floodplains, which are low-lying flatland next to a river or levee, which is prone to flooding. So we have this part of land right here, beside the river channel, and they are basically flat land, where it's good for farming and building structures or building houses. And for deltas, they are the low-lying deposits of sediment found at the river's mouth. So we have this graph right here. We have the river mouth, and then we have deltas, which are these parts right here. And as mentioned just now, the heaviest particles deposited first, and the lightest get deposited last. Then we have river opportunities and hazards. So here are some notes. Rivers present a lot of opportunities, and that's why people decide to live near or close to the river. But there's also lots of hazards associated with it. For example, erosion and flooding. Starting with opportunities though, they present as a source of food due to, let's say, seafood or fish that they can catch. And seafood's for sea and ocean, obviously. And then we have rivers that can be used to generate electricity and to transport goods and people around. And as I mentioned in the lower course, they have floodplains, and they are flat, and the soil is full of alluvium, which makes it really good for farming, as the land is fertile and it's easy to build constructions. And then we have hazards, which, for example, as I mentioned, are erosions, which will lead to loss of farmland and housing, and flooding, because living next to a floodplain, although it's good for farming and good for construction, it's prone to flooding. And then we have more notes on flooding. And it happens when the water in the river channel reaches the top of the banks and spills across the floodplain, which is quite obvious and quite self-explanatory. And this occurs when the discharge of a river is greater than the amount of water the river channel can carry at any given point. So it's almost like it's exceeding its carrying capacity from the population topic. And the river discharge is the volume of water flowing through a river at any given point. So we have different notes on flooding. We have the causes of flooding include heavy rain or like long period of steady rain. But there are also benefits to flooding, which includes it replenishes the groundwater and the water returns the nutrients to the soil as it can carry nutrient-rich sediment. But the downside, which is very much more significant, it'll cause the destruction of farmland and crops and damage to housing. And it'll also cause the increased risk of waterborne diseases. And then we have managing impacts of flooding. And there are a lot of different ways to manage the impact of floodings through soft engineering and hard engineering, where soft engineering basically includes afforestation, land use zonings, and river restoration. And hard engineering is more like let's say you build structures to prevent or to manage flooding, which includes building dams, building levees, artificial levees using concrete, and straighten the river channel. Then we have the case study for the opportunities presented by a river or rivers, the associated hazards and their management, which will look into the Nile River. So here are some notes. The Nile River is more than 6,600 kilometers long, making it one of the world's longest rivers. And it flows from south to north through Eastern Africa right here. So we have Africa right here. It goes from south, which is elevated land, up to north, where it goes out from Egypt right here. And the source up here starts from the river that flowed into Lake Victoria, and in modern day we have these countries that are there. And it empties into the Mediterranean Sea via Egypt. And these are the opportunities that the Nile River presents to the people who live near it. So, as mentioned just now, the Nile River provides food and resources to the people living around it, and has a reliable and rich soil for agriculture around the floodplains. And here's some statistics. And in the old times, the Nile River was the main trading route for boats and ships, providing basically ancient Egyptians to foreign trades and cultures. And also, the Aswan High Dam was built to increase the amount of hydroelectric power, or HEP, to regulate the flooding at Nile, and to increase agricultural production because it basically provides both electricity and water. And then we have hazards associated with the Nile River. There is a large-scale heavy metal pollution and coastal erosion happening at the Nile River, which basically threatens the people who live close to the river and who are dependent on the river. And it is estimated that around 60 million people will be affected by the metal pollution and the coastal erosion at the Nile River. And Nile River has also very dangerous and venomous animals, or snakes, hippopotamus, and deadly mosquitoes, as well as crocodiles. And also, a dam is under construction in the upstream of the river in Ethiopia, which basically is part of the Nile River, which will lead to rising sea levels and saltwater intrusion downstream near the delta, where saltwater intrusion basically means saltwater enters the fresh water in the river. And there are regular floodings in the Nile, although flooding brings in rich soil as it deposits silt, which will increase the fertility of the land. Because it's very deadly and people might not have the necessary equipment to manage it and to manage its impacts, it actually causes a lot of damage to the people that live near the river, which the house will get destroyed. And lastly, we have the management of the Nile River. We have the High Aswan Dam, or the Aswan High Dam, and it was built to increase the amount of HEP, the hydroelectric power, and to control flooding. And the lake behind the dam is called Lake Nasser right here. And here's some statistics. The dam actually provides a HEP output of around 2.1 gigawatts, which is at least half of Egypt's electricity, which is insane. And without the dam, because the dam managed flooding, without it, the Nile would flood each year during the summer. And to further manage the river and the different pollutions that are happening there, there's an approach paper that's called the Nile River Revival Action Plan, the NRAP, and it's been approved by the local government at an estimated cost of around $120 million spread across a period of 100 years. And here are the goals of the paper, or of the plan, which is to reduce salinity levels and to address environmental degradation and to reduce heavy metal pollution happening in the Nile River. And that's it for this video for 2.2 for rivers, and I hope you all enjoyed this video. And if you need any more learning resources or any teaching resources, check out my website in the description, or you can type it out in your browser at www.makesiteasy.com. And I hope you all enjoyed this video, and I'll see you all in the next video in 2.3 for coast. And that's it for this video, and I'll see you all in the next video. Here's to learning made easy.